Hi. This playlist comprises 3 short presentations addressing the subject of finite state machines, and this first one is related to their basic concepts. After watching this presentation, I hope that you will be able to explain what this type of circuits is used for, and also to differentiate between the 2 main types of finite state machines that are known as Mealy and Moore machines. Please recall from a previous presentation that finite state machines differ from regular sequential circuits because their state transition diagrams do not exhibit a simple and regular pattern. And for that reason, the next state logic in finite state machines is designed specifically for each case, following a design method that usually starts by drawing the state transition diagram, which defines the behavior of the finite state machine. But let us start by the basics, which in this case consist of distinguishing between the 2 main types of finite state machines called Mealy and Moore machines. The difference between these 2 types is illustrated in this slide. In the case of Mealy machines, the external outputs that you see here depend on the current state, but they depend also on the value of the external inputs. And what this means is that if an input changes, then there may be a change in the outputs, even if there is no clock transition. So the Mealy outputs are therefore asynchronous to the system clock, and actually more than one output combination is possible for a single state. On the other hand, in the case of Moore finite state machines, the outputs, as you see here, depend solely on the current state. And in this case, what this means is that an output can only change value when the finite state machine moves to the next state, which will take place only when there is a rising edge in the system clock. So this block diagram brings into evidence that the Mealy outputs depend directly on external inputs, and therefore a change in the input can cause directly a change in an output. That's not the case of Moore outputs, which depend only on the current state. Well, finite state machines, either Mealy or Moore, are normally used to build small sequential circuits that cannot be implemented using regular structures like counters or shift registers. A sequence detector, as illustrated here, is a good example, and you may try to draw a state diagram for a one input and one output circuit that is capable of detecting when the input bit stream, represented here on the left, comprises the pattern 10011 highlighted in red. The behavior of this finite state machine can also be illustrated through its timing diagram that I have represented on the right. Finite state machines are also commonly used as the controller of more complex architectures referred to as finite state machines with data path, or FSMDs, which we have already referred very briefly in a previous presentation. In FSMDs, the finite state machine used as a controller generates the control signals for all the blocks that are present in the data path. A microprocessor can be seen as a complex FSMD where the controller is the finite state machine that implements the instruction decode and execution control unit. We will use FSMDs in the second and third coursework tasks where we will employ finite state machines as their controller block. Thanks for your attention.